Allez-y, Jawad.
C'est bon?
Oui.
Okay. Good morning. It's my pleasure to introduce Professor Brisoni. This is his second participation in the conference. The first time was in 2014 during the second edition in Rabat. I would like to thank him. Currently, he is a full professor at the University of Genoa. His work on research development, project involving innovate modeling, interoperable simulation, artificial intelligence, chaos theory, intelligent agent, design of experiment, serious game, virtual and augmented reality. Particular attention was focused on the application of neural network, genetic algorithm, knowing based system and physiologic logic to understand plant problem combine the use of modeling and simulation. He has written more than 250 scientific papers in international journal and conference, in addition to book technical professional report with major companies like IBM and Ford, and agency NASA, NATO, and US Army. His CV is so rich, and I invite you to see it on the conference website. Thank you, Professor, and please go ahead.
Thank you very much, Chairman. I'm very glad to be here. Bonjour à tout le monde. Je suis Agostino Bruzzone et je vous salue de Gênes. Je vais faire une sharing of the screen, but I feel that je m'excuse, mais je n'ai pas l'habilitation de faire le share de le screen. Est-ce que vous pouvez me le donner pour montrer ma présentation? Joseph. Je ne peux pas faire le share de le screen. I cannot make the screen sharing. It's disabled by the host.
Youssef, what's yours?
Maybe now it works. Now do you see?
Yes.
Okay.
It's good.
Okay, so you see the screen. So I'm from Genoa, as I said. Thank you. And je voudrais remercier toute l'organisation pour les efforts qu'ils ont fait. Vous savez que Gênes, c'est une ville qui travaille beaucoup par siècle dans le secteur de trafic à la mer, des activités du port, etc. Et je suis très heureux d'être ici et d'avoir la possibilité pendant cette situation d'émergence de faire ces présentations au regard de comment on peut développer des solutions innovatives. Au Maroc, où il y a beaucoup des activités, et c'est une très bonne coopération avec toutes les différentes organisations, et je vous remercie les universités et les institutions qui ont permis de faire ces choses, mais surtout les personnes qui ont travaillé pour ça. Je voudrais faire la présentation en anglais, s'il vous plaît, parce que mon français, c'est pas très bon. We will talk today about the use of innovative techniques such as artificial intelligence, intelligent agent, modeling and simulation, and data analytics in order to support, let me say, the strategic decision making. Indeed, there are new initiatives based on the use of strategic engineering. That is a new discipline that arose around 5 years ago in MIT, in Boston, let's say. It's Cambridge, but Massachusetts, the side of Charles River, respect Boston. And we was adopting that, and we create some a very active group on this. And the basic concept is to use in closed loop this technology. This technology, let me say, from some point of view, are pretty innovative, but same time they exist since a long term. Let me go through artificial intelligence. You know, deals with the capability to develop some kind of algorithm, system, architecture that could reproduce some kind of intelligence. And even intelligence is very challenging to be defined. There's a very good way to test that was suggested by Turing, that was obviously one of the major fathers, but almost everybody now, after the movie on Turing life, is realized that the preliminary study was existing still during Second World War. So it means about 70 years ago, 2/3 of a century ago. And if we talk about modern simulation, I had the pleasure to work and to talk several times with John McLeod as one of the founders. He's the founder, in fact, of the Society for Computer Simulation. And in 2003, together in San Diego, we celebrate 50 years of modeling simulation. That means that the events, first major event was organized in California, now two-thirds of a century ago. And even in this case, at that time, there was not even existing computer in modern sense. There was analog computer, not digital computer. But for rocket science, for aeronautics, just after the Second World War, there was an explosion of using modern simulation. So it's an edge technology. It's very advanced. It's becoming very popular, but it exists since long term. And if we talk about data analytics, I always stress that the Romans, 2,005 years ago, they was using moving average and weighted average in order to forecast what could be demand of wine from Spain, at the time Iberia, or from Greece. So these technologies are new, have a huge potential. There are many papers in this conference that point out of it, but in fact they exist in long term. So what is new around the table? The new is obviously that the boundary condition change. It's not only that we have more expertise in developing algorithms in this field, but it's also that we have the capability to access many more data than in the past. And this provide good opportunity, even if it's a challenge, because normally these big data are affected by massive information. So combining all together could be make a major difference in respect what we was doing even 10 years ago. I always stress that the industrial plant was transferring data through the web at that time, even in the 80s, or even by maybe it was not web, maybe it was other kind of data interchange, but there was transferring data. But now it's different. At the time, we was getting from a power plant 4 times per day around what was the equivalent working hours that could allow us to understand how much was stressed the turbine. And it was coming from Asia to Italy, to make an example, or to US. But nowadays we get 1,000 of variable each fraction of second. That means that nowadays we can even measure some kind of vibration, some kind of symptom that could suggest us there is an incoming pending failure that maybe could be prevented by some action or by some anticipation of some inspection. And this obviously make completely different the way that we do, even if some of the concepts are still there. And obviously mobile communication, digitalization of company changes drastically the sector, and this is true even on the sector, obviously, of logistics, operation, and management. So I will give you this speech, try to introduce some of the basic concept and maybe some of the examples. I was even giving a short set of reference as well as some video that could provide additional information. In case if you visit this website, you can find further information about what we call strategic engineering. As I told you, strategic engineering is a new discipline. The concept is to use exactly modeling, simulation, artificial intelligence, data analytics, intelligent agents to be used in closed loop with reality to support the decision making and to support decision makers. So just one word about myself. As was pointed out, I'm professor at Genoa University. We create a network that is called a simulation team that's specially focused on the application and development in the sector of simulation. Is all around the world. We have other prestigious universities such as University Autónoma de Barcelona. We have Riga, La Rioja, Marseille. We have Bordeaux. We have Universidad Federal de Rio de Janeiro. We have KAIST in Korea, and so many center around, and even spin-off and startup companies. And currently I'm serving as president of this organization and founder. We are quite active in this sector, let me say. About my group in Genoa, we work a lot in use of artificial intelligence simulation to support decisions. In fact, we activated since a couple of years Strategos. Strategos is the first Master of Science degree. That means the last 2 years of the current Bologna structure of University of Engineering in this discipline. Is the first one in Italy, among the first one worldwide. And we emphasize that as a stronger connection with industry, with agency, institution. We cooperate with NATO, we cooperate with Water Academy and United Nations. We work with major companies from Accenture to Hitachi, from Leonardo to Thales, BDA, and so, and many even small, medium-sized enterprise that sometimes are very active in developing concepts. So what is strategic engineering? The idea, as I said, is to use these innovative technologies, thanks even to the support available by the big access of large quantity of data, to take them, filter, process, elaborate, fuse data, and then get an understanding of what is going, and using such to feed models and simulator to predict what will happen, and use that to support decision. But it's not finished because it's in closed loop. So it means that based on the action that we do, we continue to measure on the field what is the change of the situation. If our model was giving good figure and forecast of what was going to happen, and use some kind of machine learning process in order to fine-tune the model and correct them. Okay. It's not only about methodologies. Obviously, there is a system view and an architectural need, but it's even about people, because to succeed in this sector, I feel it's required to have some people that is able to talk with decision maker, understand their need. Some people that is talking with the developers, because in big project there will have many different skills required, and to draw by themselves the architecture and the algorithm. And it is necessary with decision maker to create really a trustness, because decision maker are currently filling some gap between analysts, people that do analysis, and people that take a decision. I feel that if we look around, unfortunately, we can realize that there is a big gap in terms of capability to develop strategies. No, I feel that if you think about what is the expectation that you have, let's take just COVID-19 as an example. We have seen country after country that are shifted, let me say, in contamination over the timeline, that don't get the really benefit of what the other one was doing. Now, in fact, obviously, we call it pandemics, but let me say that in some way is a plague, is a pestilence. But obviously, a country cannot be ready to face such kind of crisis because it's too big. But at the same time, we can say that there are better ways to face the crisis than other one. Decision can be much more, let me say, robust. You should have a view. And currently we see around the world that most of the case there is a lot of confusion, no capability to stay on a single and clear line with persistence. And so this obviously is a pain, but I feel we don't have to use COVID. If we look around in industry, in politics, in environmental development. There are a lot of examples where we lack some kind of real strategy. It's very important, I feel, to use to start from the definition of strategy, because often there is a common misunderstanding about what is strategy. There is a common feeling that strategy is to do plan, medium, long-term plan. Now, I feel it's very good, the definition of strategy that came from General Jomini. Jomini was one general of Napoleon army that had more a theoretical focus, was, let me say, is considered with Clausewitz one of the two biggest person of modern study of art of war and strategy. And in fact, by the way, Jomini, maybe several of you knows because he introduced the modern meaning of the term logistics. Before, logistics was just meaning computation from Greece. It was introducing in Le Précis de l'art de la guerre le concept que la logistique, c'est l'art de mover les armées. So it was introducing the modern concept of logistics that was taken after 50 years from Mann in the United States and then diffused it around. And now it is common to use this word. It is just in this sense. It is a very fundamental activity, not at war only, vice versa, much more in industry, in business, organization, but even in society service. And Jomini in the same book was stating that la stratégie, c'est l'art de bien diriger. So strategy is not the planning. Strategy is the art to well manage things, to achieve the result. This is very important because we talk a lot about strategy as concept, then say we have a good strategy, but we fail. No, this is not correct. Strategy is not in planning and talking. Strategy is in well-doing and achieving the final result. And to do that, we need nowadays supports that could be stronger than the old sand table that was used by Julius Caesar with a stick to draw the force of the armies. Obviously, each system could work. The technology is not the solution. The technology is a tool to provide a better understanding and to support this kind of decision. The example came, for instance, from port. What it means to do strategic engineering? It means that nowadays we can collect many more data from the ship, data from the port terminal, data from the shipping organization, etc. Getting a better picture of what was happening. And this obviously could be very important for us to understand what is going up to now, even mostly in real time, because in this sector, probably few minutes of delays is not a major issue. But at the same time, we can feed by this data our simulation models and to have a constant, up-to-date situation with a model that is online with the reality, some kind of digital twin that is keep hot respect reality, can allow us to make a forecast about what will happen, not too much to have a crystal ball, but to evaluate risk, to evaluate alternative, and even to put, let me say, our decision in it. Because another example that came from COVID is that we have thousands of, let me say, statistical experts and scientists that make a very deep analysis of the curve of contagious, casualty, etc. And that's important, but looking at the logistic curve, you can understand what happened in the past, but you cannot forecast what will be the result of your decision. If nowadays, for instance, we are in Italy talking to lock down, as used to say now, some activity we already done for some bar, etc. And after 6 o'clock at the moment, PM. But if you use such a statistical curve to analyze the problem, you will see what happened up to now. If you take a decision, you will take time to see the result because the physical phenomena, the epidemiological phenomena, the socio-economical phenomena have an inertia. Just if you consider the disease, if it takes as average 10 days to show up, and it show up just in a small percentage of the people because a lot of people are asymptomatic, probably you will be able to measure the result in 2, maybe 3 weeks. There is even some noise over, so the noise need to, the signal that what you measure of the effect of your action should go overpass the natural, let me say, variance of the phenomenon. So maybe you will know in 3 weeks if your decision was good or bad, and how good or bad it was. In 3 weeks, probably it's too late, because if we talk about this case with current rate, we're talking about having a multiplication factor that could be 2, 3 order of magnitude. So it could be a very big issue. It is a demonstration that statistics is good, but you need model and simulation to evaluate the impact. Model that trying to get the correlation among the factors. Then you can use this one to provide information to the decision maker, evaluator, and they can decide, but you should close the loop, because many times the model could be incorrect, data that you collect could be improper, affected by bias, the scenario change. We always talk nowadays about the change on the boundary condition, but in our case, it's not change in boundary condition. It's even that we have other partner. Now we don't, in the case of the virus, hopefully virus is not our enemy in terms of an intelligent enemy. But in terms of logistics, in terms of operation and management in industry, we have competitor, we have other player, maybe not competitor, but they could take decision that change the scenario and affect ourselves. Many times the other partner, if they are competitor, they react to our decision. And so then we needed to continually update our view and correct. So it's not only to correct the model, to tune the model, but it's even to corrected action, to do strategy. That means to act, to do. Facta non verba was used to say the Latin. And in strategy, we have to do that. And Strategos is devoted to prepare new generation of engineers, as strategic engineer is devoted to prepare architecture solution that could act to provide strategic advantage to decision maker, to get a better understanding on that. There is a very good quote that I use that is from Socrates, 2,500 years ago. This was written by Plato in Laches dialogue. And this was used to say that the strategos, that at the time, as probably many of you know, was a general or an admiral of one of the city-state of the ancient Greek. He would say a strategos is somebody that have an art. The art to know better, a little bit better than other, what is happening and what is likely to happen. And by strategic engineering, we are devoted exactly to this task, to create tools, architecture, solutions that allow to understand better what is happening, what is likely to happen, okay? I would like even to point out another important aspect in strategy, and I will use a quote from one of another person from Genoa like me, the much more genius and famous, that is Cristoforo Columbus. I know that around the world, many countries claim that is original from their country. Now I don't want to take this point. However, Cristoforo Columbus was a genius. There is no doubt about that. And he was saying something interesting in his memories. He was saying that if you have to create a strategy, you have to look at the goals and the objective as tools. So, and you have to change, modify, and adapt based on your priority. Eventually dropping out someone, creating new one. This is very important because even in this case, looking at the industry, often we see company that due to the specific short-term goal of the quarter, they completely miss the proper strategy, and managers too, because they get assignment in terms of objective that don't allow them to have a persistence in policy and strategy that could be successful in general term, not on long term, but even on short term. And this is a difference between somebody that have a strategic view and somebody that don't have, that is able to adapt the goal and objective. And strategic engineers should help in doing that, because you have to understand what is your final goal. What is your final goal? We was mentioned the case of the crisis. What is your final goal? Is to shut down the pestilence? Is feasible? Is not? Is to maintain economy at some level? Is to preserve the policy and the institution? So you have different priority. You have to identify, you have to do act to achieve this one. You have to monitor if you're getting result and to identify if your choices are correct or no, or maybe are not more because the situation changed. At the beginning, some solution was very smart. Nowadays, maybe some solution is not so useful. I mentioned just the point, currently in Italy, we're talking about making some kind of lockdown just in some town. Considering there are probably millions of people around infected, if you make, let me say, a block of a town, probably is not so effective for the rest because the virus is already there. I don't want to give a solution for this case, but it's obvious that we need models. We need the capability, artificial intelligence, to fuse data, to select data, to understand what happened. We need the people that work side by side, not in a different room with decision maker, and understand what is their problem to introduce in the model, at the same time to understand the result of the model and make sure that decision maker have a clear understanding of the situation. Then decision could be dictated by other criteria that overpass engineers, obviously. But it's very important to understand because it makes the difference. And you can, in this case, you can save life, you can save the society. In other case, you can make your company profitable and successful and developing around, as well as your country and so on. One important concept I feel in strategic engineering is the importance of intuitiveness. What I mean, nowadays technology allows us to make it much more easily understandable. This is an example that you can see. This is a simple, we call spider, is a cube 2 meter by 2 meter by 2 meter and 6, where 3, 4, 5 people can go inside, get completely immersed. It can be made on 3 screen, 4 screen, you can have a floor, you can have a roof, it can be closed behind you, it's touchable. So if you go inside, you can see a situation, you can touch, get information, is interoperable. What I mean, it means that simulation and models that are used in this framework can be connected with other models. So if you have a model of economy, it can be connected with a model of a crisis. It could be connected with a model of weather condition and get let me say, a complete federation of model running. So, but important aspect is to make it intuitive, immersive, interactive, because the problems are complex. To get understanding of these problems is a big challenge, and we need the new ways. Obviously, extended reality, that is the combination of mixed, augmented, and virtual, is a good way to do. Is not only, let me say, in terms of using such kind of device or to use HoloLens or other tool, but is to make it easy to use, because decision makers don't have time. They are used to go through huge tables. This is some kind of luxury service, but is even very good to get them engaged. Engaged means they get feeling and fragrance of what the model and the analysis suggest, have the capability to make change, not requesting a change or get an answer after weeks or months, but get it immediately and make it reactive. And due to the fact we are interconnected with data, they are mostly real time, at least for this kind of application. They came from social, they came from the company digitalization, the institution digitalization, sensor network, etc. We can have a direct sensibility to what is happening, and that's very important. Another aspect is that I feel these techniques make sense if you apply in real problem. Real problem usually are the more stimulating for young researchers, scientists, engineers, and are even the more challenging. We have a strong cooperation with many organizations, from Sovereign Order of Malta, that is a humanitarian institution that support people of all ethnics, all religion, since over 1,000 years. Nowadays are pretty active around the world, and to going to Accenture, that is a classical, very aggressive consulting firm, from NATO Center of Excellence to the Hydrography Institute, from MBDA to Expo, RINA, We have all the industries such as Tenova, that is a classical major player in steel making, to companies that are very dynamic like Axpo, that is, let me say, an energy provider that use different solutions around Europe. Nemea and Simple Future Vega are examples of Society Rulex that develop engine, artificial intelligence solutions, so medium-sized enterprise that are active. We have all kind of sector from, is not the, a lot of people think Strategos could have a strong liaison with defense. Obviously, some of the players are in defense like Thales, Leonardo, and BDA, but and even another one. But in reality, the hugest potential to be achieved easily is on industry, because industry and business have a huge need, logistics obviously too, and management and operations. There is even a big potential in society, institution. And for instance, we are working a lot on water strategy. That is a major issue that probably could be critical in not so many years. We talk about a decade, and even less maybe. Let's hope that for the better, but we need to prepare for the worst. And obviously in that sector, even there is a huge potential. It's more hard because obviously industry make profit, is ready to invest on new solution, on young people, and while institutions have a more let me say, they are slow mover, unfortunately, often, so it's not easy, but there is a big sensitivity on this sense, and the partnership is a good example that we have. Let's take a look at sea and naval strategies and the current risk. If we talk about the naval scenario, etc., the threat has changed along the last decade. Once we had a clear, let me say, kind of foe, of a clear kind of threat set. Nowadays we have completely different one. I make an example of Deep Horizon, the exploration rig that had an accident several years ago in the Mexican Gulf. Feel is a very good example of a mega ecological disaster that cost many billions of dollars, that have a huge impact, not only in terms of, let me say, money, but on the society, because if you destroy fisherman industry and you destroy the boat repair activities, you impact on the coast and tourism. You have a huge disruptive impact, very large, as we can understand maybe just now by the case of pandemics. There is another example of something huge that overpass our capability to react often. And in that case, we have almost all the solution to face the different aspects, but we never put together the capability to make them interoperate, to create a scenario that is a combination of all the aspects, is crucial. We had all the single component to train the pilot of helicopter, the tug operator for firefighting operation, the control room of the oil rig, the offshore rig platform. We have the Coast Guard, the models, etc., but we never put them together to analyze a scenario like that. And obviously it was a problem, because then you cannot react. So logistics is a perfect field where to apply these techniques, because logistics is clearly affected by what we call VUCA factor, volatility, uncertainty, complexity, and ambiguity. And because it's open, logistics, okay, we have internal logistics, but even internal logistics strongly depend on the feed inbound, outbound. So if your supplier have a delay, the lead time is not robust, they will impact on your organization as well as production. Let me say, if we talk about external logistics, this is huge, and many factors are affecting what is the decision that you have to take, and even strategy, because strategy maybe doesn't deal with the specific tactical, small tactique, la grande tactique qui disait Jomini, but, or with operation, as we say nowadays, but often strategy is to review the way we do operations. And in this sense, obviously, modern simulation is fundamental. Here we have example to train, create a new way to train, for instance, crane operators. We know that, for instance, container flow, currently there is a problem about the growing size of the ship and the capability to unload them in convenient time. And the technology to go fast and faster is already there since a decade, but it's not so easy to do because when you accelerate, humans can make errors that multiply the effect of the error and slow down the operation. So you go very fast in picking a container and move it. But if you introduce some wrong action, you start to oscillate and you spend more time in the whole operation to stabilize it. What is the solution? I don't know, but we know that we have technology nowadays, and by this approach of strategic engineering, maybe we can prevent this error with some real-time smart systems to support them. We can develop solutions that are aid of the operator and so on. Okay. In addition, we have completely new component over the market. I feel about autonomous system, but as I said, it's not just about what I call iron. You know, I'm original. I started my scientific study when I was a Navy officer, and in the ship construction, that is not my field in any case. We say always that it's crucial to start to cut the steel as soon as possible to create a ship. So we talk a lot about iron. Iron, in this case, I mean the physical objects. Now, the drone, the robotic solution, the autonomous systems, obviously are a big potential, could be a part of the revolution, but it's even about how you introduce in the process. No, we had the case where we start to use flying drone to deliver goods that could change drastically the fact. In this case, we have an example of using similar system to make inspection on offshore platform. On the bottom left, you have an example of robotic system they are very simple, are similar to Roomba that you can buy for a few $100s for your home to clean. That this one can move around in a warehouse to deliver goods, to move even shelves by themselves in very simple way. These are multiplication factors that could change drastically the way we do operation. And if you marry, let me say, if you decide to take this way, you will have a lot of challenges. Probably you need strategic engineering to solve, but you can have a real strategic advantage and even problems, obviously. And so on. Another classical aspect is that when we do that, often we couple the real system or physical system with the, let me say, cybernetics. You know that Industry 4.0, introduced by Germany a decade ago, is strongly overstressing the concept to have a cyber physical system and to make them available through the web. Some friend of me that work in a major Italian and currently Italo-French, US automotive industry is say that Industry 4.0 was overpassed due to COVID by the fifth revolution in industrial sector that overstressed the importance to be able to operate remotely. But obviously, Industry 4.0 is even a starting point to do things. We have to think that when we connect, example, like in the case of transportation, we have not just cyberspace, we have even space that provide huge capabilities by satellite service, etc. Obviously, they go through the web often. This is a big potential, but is even a big vulnerability. No, I can say that in the traffic, there was an experiment carried up more than 5 years ago. Experiment, not let me say experiment. There was event that was happening where there was used to confuse system like Google Map or Weather that was taking information about traffic to create fake traffic jam to generate huge, totally blocking for a day traffic jam other place. So it means if we use satellite positioning, but we have a GPS spoofing action, it was carried out a very interesting test by University of Texas over Egnotti in Italy, where you can confuse the GPS of a ship, of a vessel. Obviously, you transform it, let me say, in a sailing bomb that nothing can stop. Because even if you have a fighter that could bomb this ship, considering the size, and and the mass over there, you cannot probably stop if you send against the port, if you send against an offshore platform. And this could be deliberately by terrorist activity, by, let me say, hostile activity, hybrid threats, but could be even done by an hacking or by some kind of just errors, etc. So this kind of vulnerability should be addressed. And when you develop new solutions, strategic engineering should be used to don't underestimate this aspect, because this new vulnerability could have a huge impact on operations. Let's say that in this sense, it's not just about very dynamic system, even what we consider almost static system. You know, I'm from Genoa. Genoa experienced, I don't know if you remember, but 2 years ago, we have a really dramatic event when our major bridge collapsed, creating even over 40 casualties and completely blocking transportation. Nowadays, after just a little bit less than 2 years, we reconstruct the bridge, but we have to say that in this year, the port that was strongly affected was reacting. It was creating alternative routing. There was a subdividing activity in the port. There was the whole town was self-reorganizing. There was a huge introduction of smart work much before COVID, to reduce the people that should use transportation to travel along the Genoa, because Genoa is a town less than 1 million inhabitants, but is facing the sea with very tall mountain on the back. We have Alps on the back and sea on the front. So we are very narrow and very long. Genoa goes for dozen and dozen and dozen of kilometers from one extreme to the other one. And so it means that there is only this way. There are no alternative way because of the morphology. And so there was a huge effort to do that, to rethink about transportation, etc. It's a good example. And nowadays, strategic engineering is continued to be used to put intelligence in monitoring and controlling situation of critical infrastructure, even bridge, even transportation, because nowadays we can do things different. We can use drone to inspect a bridge in place where you cannot mostly access, or you can access, obviously, but it takes time, equipment, and then after you make the planning initially, due to the cost, due to the complexity, often you stop to do and rely in average estimation that are not good. Today, there are very good sensors that could track it optically, by satellite, by many methods. You can combine that with models. You can make to get the picture to understand what to do. And obviously, it is strongly rely on the capability to create digital twin that are not created once, but maintained in strong connection with the reality. They are not just, let me say, configurational, but they are simulational. That means that they can reproduce function and actions. Urban logistics and transportation is another field where it's very crucial. This one, we have new way to think about transportation. You know that mostly no solution is possible traditionally, but for instance, why? Because traditionally, urban transportation is very chaotic. So we have urbanization that make it each day more critical. I feel that probably in Rabat and Kasai, you understand clearly the problem, but it's true even in Rome, Genoa, Milan, Jakarta, etc. But you have to consider even one point. We have new capabilities. I was in Guangzhou 2 years ago, talking with the chief of research and development of Alibaba. Alibaba is a major retailer. It's similar to Amazon, just a little bit smaller, but maybe faster growing. Is Chinese. And as Amazon now, in addition to retail, their major business is cloud, because they develop cloud infrastructure for doing retail over the web. They now provide service to third party. And in Guangzhou, there is a very efficient way to manage, let's say, many efficient reorganization of the town. Each single intersection have tracking capability of vehicles, cars, trucks, bus, etc., scooters. It's based on cameras, even all cameras. If you drive along the evening, you will get all flash at all the intersection among the street, because they use the flash in order to collect the plate ID of the car and to detect and track. And that's good or bad, depending what you see in terms of a little bit invasive of your privacy, but you know that by your mobile in your pocket, you are already totally invaded. But what's interesting is that Alibaba was starting a new project. They said, maybe we can use on our cloud some algorithm to optimize the traffic based on the information, the huge big data that we collect of each single vehicle movement in the town in real time. Now, you know that if we talk about mass transportation companies, and if you get just a 10% reduction in cost improvement in the quality of service, you can save millions of dollars. I don't talk of town like New York City or Manila, Metro Manila, or Tokyo. I talk even of cities that are just a few 100,000 people. And over there, they spend often dozens of millions of euros for public transportation with very low profit. If you can save just 1 to 2 million for each of one, you will have thousands and thousands and thousands of applications around just Europe or US or other places with a cost that is marginal, because once you have developed this algorithm and connected the system, you can reuse this kind of algorithm. So this is a business that up to now don't exist, but can you imagine in the future that you can be a provider of such service to mass transportation to make some kind of improvement and to be paid by performance? Maybe very small amount of money, but if you have 4,000 town of medium size, medium cities, small size, and you take even 10, 20, 100,000 for each, it will be billions of euros. That's another good example. Let's talk very quickly, because I know that I'm running out of time, about COVID-19. COVID-19 is another good example for strategic engineering, because I feel one point of COVID-19 crisis is that a lot of people talk about decision, open school, closed school, open restaurant, closed restaurant. In reality, my feeling, we work in several groups on it, in NATO, in different countries, in Germany, in Singapore, in China. There's not such kind of decision. It's not the decision. You are mostly forced. You cannot shut down everything, otherwise the people will not support. You have to support the strategic layer, healthcare. You have to support obviously logistics, that's fundamental. You have to guarantee distribution of food, distribution of power, energy, water, gas, communications, okay, security, etc. In this sense, this is not an emergency. This is a crisis that is unfortunately persistent at the moment. So what is the solution as an engineer? A solution as an engineer to find new solution, new process to improve, but it's not easy. I mean, maybe we can use EVC to decontaminate goods, but we need to be able to analyze data to verify if it makes a real advantage or if it's not crucial. We have to pay attention to develop intelligent systems that avoid that the truck driver, that if is in his lorry, some kind of automatic system, when he closes the door, aerate the goods with some EVC or ionization system. When he arrives, he don't get let me say, hurted, wounded by something that is more toxic than COVID-19, because we cannot expect the truck driver will operate as a researcher in a lab. If it's arrived after 9-hour drive at 3 o'clock in a place to unload the loading, it's evident we need to provide not just some device that decontaminate, but some control, some smart aid, etc. But this is an example. We have to do a lot with not only physical fact, iron, but even a lot with procedure solution that could elaborate data. So with some colleague, one analysis is to create a sensor network to collect data from sewage to analyze in what part of the city there is a major level of contamination, and to use this one as a feedback about measure that has been put in place to see their effectiveness. At the same time, to use them in a closed loop with decision maker, just to inform, for instance, each medical doctor when you have to do a visit, if this subject, based on what the work he does, where he lives, what is his profile, what is their some basic biometric, not measured when he arrive in a place, but measured over the time with some simple system that could be obviously accepted by the person, could reduce the risk to expose a medical doctor to some risk of contagious. If you reduce just 20%, is a huge result. So these are examples of new things that we can do. In the lower left, you have an example we was doing since 7-8 years, solution to analyze how to send autonomous system, robotic system inside industrial facility, chemical plant, nuclear plant, etc., to make inspection, to collect people that has been contaminated and to bring them out in a safe area. This obviously was research. Nowadays we have project with steel industry that is not, let me say, it's very pollutant in many cases, but is not so crucial as chemical or even nuclear. But you can use the same system, not just for managing emergency, but to go to do inspection in place where inside the industrial plant you cannot access easily. This could change completely the profile, making completely different. You can do many control. You can improve the efficiency. You can keep people more safe and could be much more competitive. And this obviously goes everywhere. Safety and security issues are major aspect. I feel that this is another aspect where we have a huge potential. And defense, obviously. These are examples of things that we are doing in the cyber layer, in the physical layer. This is SWAT. It's a project we are carrying out about using autonomous system to be delivered and even flying UAV and USV on the surface, AUV underwater, autonomous underwater vehicle, to make surveillance, persistent surveillance of strategic asset. You know, at sea we have huge strategic asset going from pipeline to off-rig to ports to power plant on the coast, as well as in cables and so on. But we don't deal just with, let me say, the evil guy. We have even to face an issue like crisis that is going around. I make just a quick example. First of all, a very important aspect in this sense is to create digital twins. Here we have example of things we have done, from food, beverage, machine, to shipping, to offshore, where we create models that are, let me say, the twins of real system. We keep them aligned to support decision. We can use artificial intelligence in connection with the extended reality. You can see on the left an HoloLens where a person that maybe is not skilled or don't know the configuration can go in front in a crazy wreck of a network connection and get direction to what to do. We could have a digital twin to test what happens if he unconnects something and connects something else. And then obviously this is a multiplier factor. In the past, we was using to operate on an offshore platform because sometimes you cannot send expert there due to the weather condition. Nowadays, is a huge potential for doing other facts. In the below, there is somebody operating similar way on electrical controls, but you can use it for supervising logistics. You can provide on smartphone capability. We had due to the COVID crisis and quarantine of country, we had to develop solution to be used to install machine in Indonesia, in Jakarta, when it was not possible to travel in Jakarta. What do? You send over there the material, you find some local people that you have, but is not skilled. You provide some kind of app for his smartphone that help him because it show where you have to go in the plant to put, where is the right positioning, the dimension, how to have to orient, how to need to mount. It can be directly connected with the back office where experts give direct instruction, not just as a talking or as a video, but showing exactly where you have to touch, because they have a virtual model, they have digital twin that can be overlapped with the real one. Now, this is a necessity for COVID, okay? Is an aid for facing the problem of COVID. But obviously after, let's hope, after the crisis, if I had this in my pocket, I will bring with me when I do an installation, not even in Jakarta, maybe just in La Spezia, that is 90 kilometers from Genoa, because it will help in many ways to avoid errors, to get direction, to have all in my pocket, to be able to interact dynamically. So these are, let me say, enablers. And by strategic engineering, we can design them, develop them, especially the intelligent part, and even evaluate their impact on that. And these solutions are not just about, let me say, I call a little bit science fiction. It's not science fiction because HoloLens exists since 10 years, but HoloLens are, let me say, not so diffused, but tablet. If I go in an oil platform, probably I will not give so many HoloLens. They probably will break out very quickly. It's not too much for the cost. It's 4,000 euro, but in such operation, it's not so crucial. But I can have tablet that cost less than 100 euro. I can have rack of tablet that I can take even if they break. It's very easy to use. You don't require to learn specific aspect. It's not so imprecise as it is now, this technology. It's much more precise. You can use it. You can provide augmented reality information to guide you through startup or shutdown procedure, can help you on troubleshooting, etc. And you have many of these ones that are made available by enabling technology. The concept is exactly what I explained, that we use data analytics to extract from data the understanding what is happening, providing to the analysts and decision makers. We use smart planner that use artificial intelligence to even give active, proactive solution, not to be put in place, but to be refined by experts, and to put simulation in the loop, because simulation can react to the input from data analytics, can evaluate the performance of smart planner, and can even evaluate the solution provided directly by decision maker. And all these entities, humans and artificial intelligence models and algorithms, should work all together. And this gives obviously a strategic advantage. If we think, just to close, because I feel I have maybe just 4 or 5 minutes more. Port traffic, we talk about port traffic. You know, this is classical list, maybe not really up to date, but was 2018. The traffic of major port, as you can see, the biggest port out of China are just in Singapore, as usual, Australia, and Netherlands. But let's take an example about new issue. Nowadays, we have many change. We have additive manufacturing, where we can think about to construct from dust power, from power, metal power, other power. We have autonomous system that can go in confined space where people are very big danger and reducing risk. We have potential ship without crew. We have a new solution of augmented reality. We have the polar routing that could change drastically the geo-economics, letting ship moving from the Far East and China to Europe and US through new routes, and this could be dramatically affecting everything. These are very strategic issues because you have to rethink. You will produce just the power, and you will deliver the power to produce the artifact by 3D printing. We are radius technology. What is the difference of cost? What are the components we'll do in this way and the other one not? It makes sense to use a ship without crew. Maybe we reduce low-level crew. We keep a few experts on board. In fact, the crew is not a major cost for current cargo ships. Respect the other one. I don't think there is a huge advantage. What are the implications of this one? What is the risk to use autonomous system for inspection in confined space, and so on? It takes just the case of Tianjin. Tianjin is a port that was the European gate to China at the beginning of last century, after Boxer Revolution. It's a very nice town, even with a lot of quarters that have some kind of European-like style. That is some strange in China, but it's the major port of Beijing. In any case, it's the 9th port worldwide, just 10% larger than Rotterdam, that probably even you and most of the people around the world knows as a major container center in Europe, but even in general traffic. So Tianjin was very drastically growing, considering that 1 century ago was mostly nothing, just a river port and a few docks for importing, not so big quantity. But we have to deal when we have such huge development of the town, of the traffic, even with risk. This is what happened in Tianjin in 2015. There was an explosion of 800 tons of ammonium nitrate. That was very dramatic because due to the urbanization, due to the port increase the flows, was near the town, near production facility. As you can see in the picture on the left, there was a automotive, large industry was completely flat. This explosion was huge, corresponding to over 300 tons of equivalent TNT, create 173 casualty. and a huge crater that you can see that looks something like that one of a small asteroid. There was a keel made of container flying away due to this explosion. And this was accidental, but obviously as soon as the town grows exponentially and the traffic increase, the risk and the vulnerability increase. Nowadays, unfortunately, I was involved in a workshop a couple of months ago. We have another event, same kind of material, 2,700 tons of ammonium nitrate in Beirut. That was dramatic. There was even in this case 200 people dying. That is a tragedy, but let's consider 300,000 estimate of homeless caused by this disruption. There was the biggest explosion out of military operation, probably, since our human history. There are over 1 kiloton of explosion and around $15 billion of damage. The ignition factor is different. And even in 1 century ago in Texas City, there was a huge explosion of ammonium nitrate. But the point is, the problem is not ammonium nitrate. Ammonium nitrate is not really so dangerous. It's absurd, but it's not so dangerous. Normally just burn when it generates the explosion. When there is a huge storage of it and under specific conditions, they generate the luminescence. So this is a very classical example where, unfortunately, you need use strategic engineering to prevent this kind of problem. You need to guarantee development preventing the problem, because obviously it's very easy to prevent, as we do currently in COVID, and say we shut down. But shutting down is not the solution. We need to operate. We need to be active. We need to develop solutions to deal with crisis, and we need to be able to take strategic decisions. So I thank you very much for the time. If you have any question, we'll be glad to answer. By the way, consider that in Strategos initiative, we have very happy to have a cooperation with other institutions, with other university companies, agencies, and to provide opportunity to them. We organize many workshops and seminars open to people that are interested to specialize in techniques. So recently we was doing with Schlumberger set of that for analyzing smart solution of machine learning for data analytics and predictive maintenance. We are doing about hybrid warfare. We are doing about many different sectors, social modeling for marketing or for guarantee satisfaction and development of smart city. So I will be very glad to keep in touch with you. And if you have any question, I'm very glad to answer. Merci beaucoup à tous.
Thank you, Professor, for this interesting and rich presentation. Any question? No question? I have two questions.
Sure.
How we can use machine learning to use it inside simulation or optimization?
Okay, this is a very interesting question. Thank you. The point is that obviously simulation is strongly connected, obviously, the result that you achieve with the input data that you provided. And obviously, if you use simulation for decision making, your output are affecting the reality. So if you do machine learning, let me say in the closed loop of strategic engineering, so in the decision process, what you do is that you collect the data from the field and use to refine the tuning of your model. I make you an example. Currently, we are doing a major work for retail, for a company that have revenues overpassing 50 billion euro per year. Is a major retailer. They are interested to use some kind of this solution to, let me say, finalize, support the decision about the marketing campaign. So week by week, in some couple of months in advance, they have to define what to promote and what could be the price of the promotion, what could be a mix of articles. So in this case, what we do, we use machine learning to find correlation between many factors. We put in a fusion procedure that is not just about data, but is even about information and indication by experts, because experts are aware of some expectation of the reaction of the competitor that is an added value in doing such policy. So they can refine the proposal from the smart system, but they can even suggest to the smart system there is some expectation of this customer. And this allows to find some correlation among the different products, how they will sell. But when you put some promotion in place, you have to create a scenario. And obviously, you can have many multiple alternatives. Even if you can predict the sale of a good, is not, let me say, trivial to predict, to identify the best mix for 1 week and for the following week or for the following week, because obviously you can promote something 1 week or 1 week later and vice versa, and they could have different impact based on several boundary conditions over thousands of stores over different geographic area. So the simulation is used for what? Simulation is used to predict the reaction using the expected sale that are forecasted by the artificial neural net. But in doing that, there are some assumptions about what could be the reaction that will be carried out by competitor and the reaction, let me say, of the consumers. This will happen in the future, obviously. But as you proceed in the time and you reach the future, you can measure the real performance. By this way, you can correct both the forecasting system by machine learning using artificial neural network, as well as the parameter, the tune, the different alternative strategy implemented through algorithms that are parameter driven. Normally we have an agent driven simulation, so the parameter of these agents can be corrected to have, based on what happened, a new tuning of this variable, exactly as we do. And in this way, we can progressively reduce errors. Obviously, there is even a change in the boundary conditions. So it's not true that the new tuning will be successful for the future, because if something happened, maybe the competitor will change a reaction, etc. But let me say that progressively is providing very good results. Thank you for the question.
Any question?
Je veux poser une question, s'il vous plaît.
Oui.
Vas-y.
Donc, tout d'abord, je m'excuse, je vais poser une question, je parle en français.
Pas de problème.
En partant
si
du fait que...
je vais vous l'aider.
Donc, en partant du fait que on travaille avec des systèmes complexes, l'ensemble des solutions qu'on doit prendre pour bien faire en fait notre travail, et s'appuie sur des ressources matérielles et humaines et un flux d'informations. Et donc la qualité des informations qu'on doit collecter et qu'on doit préparer et qu'on doit augmenter leur qualité, ça va influencer sur la qualité de la solution qui va figurer dans la stratégie. Ça, c'est d'une part. D'autre part, en fait, vous avez parlé du fait que dans une situation de pandémie, la qualité des décisions prises, ils ont un impact sur notre façon de faire. Pourquoi? Parce que on a une limitation des ressources, et c'est avéré que l'ensemble des personnes qui travaillent dans le domaine hospitalier, en fait, on voit très bien qu'il y a un manque en fait de ressources humaines, malgré qu'ils sont atteints par le Covid. En fait, ils sont obligés de continuer à travailler tant qu'ils n'ont pas d'autres solutions. Donc, l'ensemble des solutions et la qualité des solutions et de bien faire se heurtent à une difficulté de manque de ressources, et qu'on n'a pas une situation claire, on ne sait pas quoi faire, parce que c'est quelque chose qu'on ne peut pas prévoir et difficile à prédire. Voilà ce que j'ai à dire.
Bon, et la question que vous me posez, c'est au regard de la difficulté de faire des prévisions, de prendre une décision dans des moments quand vous avez beaucoup d'incertitudes.
Oui, et que l'ensemble, et on a beaucoup de partenaires, de parties prenantes, et donc on aura une autre difficulté pour prendre une décision, une telle décision ayant une qualité et pour nous donner une solution satisfaisante.
Oui, ça, je pense que c'est une très bonne question. On va dire deux choses, je pense. La première chose, c'est en effet, c'est une fact, c'est que toujours quand nous avons affaire avec systèmes complexes, malheureusement, nous n'avons pas très bonne source des informations. Et en général, even aussi quand nous avons les big data, on se souvient qu'ils sont construits de beaucoup d'inconsistances entre les autres, oui, avec beaucoup de détails dans une partie et complète ignorance des autres. Si nous parlons de la COVID, c'est un bon exemple parce que nous n'avons pas encore des informations qui sont bonnes, parce que si vous me disiez qu'il y a la probabilité de 10% ou de 20% ou une probabilité sur 1 million de reprendre la maladie, il change complètement le scénario.
Ouais.
Parce que si vous me disiez que le temps pour l'incubation, je ne sais pas si on dit qu'en incubation, mais c'est de 10 jours, c'est différent que si c'est de 14 jours. Si vous me disiez que je peux le prendre par les objets après 10 jours, c'est différent. Et de cette façon, on va dire, je dis tout le temps que nous ne savons pas compter les morts.
Ouais.
Pour donner une dimension de l'imprécision que nous avons au regard des choses. Non? Nous n'avons pas de bon nombre au regard des morts, qui sont les choses plus objectives qu'on peut avoir. Mais il y a aussi des conditions sur ces data qu'on doit comprendre parce que ce sont data de sécurité nationale. Je pense que si je serais là-bas, je ne voudrais dire beaucoup de ces numéros parce qu'ils sont très sensitifs. Mais ça ne signifie pas que nous ne pourrons pas utiliser ces systèmes pour supporter notre décision pour une façon. Nous pouvons, dans notre modèle, faire des hypothèses et les confronter avec la réalité. Et dans cette hypothèse, nous pouvons prendre la proposition que vous avez, qui peut dire, OK, au moment, c'est beaucoup moins létal, moins dangereux. On peut prendre la mienne qui dit, ce n'est pas vrai. Utiliser les modèles et voir cela qui match de la meilleure façon. On peut évaluer des possibilités alternatives. Une autre chose, ce n'est pas d'avoir seulement les bons data, mais c'est aussi une moyenne pour vérifier les data. Non seulement pour les vérifier, mais pour vérifier s'ils sont bien pris. Parce que quand tu vas vérifier qu'il y a des inconsistances, peut-être causées par les modèles, mais peut-être causées aussi par comme vous allez prendre les data ou comme vous allez faire les choses. Parce que peut-être vous me disiez que vous avez tout le monde qui use la masque, mais je vais voir que ce n'est pas vrai. Et en effet, dans les data, si tu prends la proposition que ce n'est pas vrai, le matching, c'est très mieux. Et la dernière chose que je vais vous dire, c'est que nous ne pouvons pas avoir la crystal ball. Nous ne pouvons pas avoir une sphère de cristal pour voir cela qui va venir. Mais on doit avoir des capacités de vérifier quelques résultats et de contrôler pendant l'exécution combien c'est la différence entre notre prédiction ou entre notre attente, et c'est là que c'est le résultat final. L'utilisation de l'intelligence artificielle, c'est bon parce que beaucoup de fois, il est vrai que nous n'avons pas les informations valides au regard de combien de jours c'est. But nous avons peut-être so many data, beaucoup de data qui sont de beaucoup de cas que si tu vas les prendre tous ensemble, tu ne sais pas si tu ne peux pas extrapoler les valeurs correct, mais tu peux voir dans une vision d'analyse des risques si c'est une hypothèse qui est valide ou non, et c'est là que va venir. Excuse-moi pour mon français parce que je ne suis pas usé de l'utiliser beaucoup. J'espère que j'ai répondu.
Another question from the chat. What software tools of simulation you use?
Il y a beaucoup. Au moment, nous travaillons dans ce secteur en anglais, en français.
As you like.
Okay, so if you don't worry, I will go in English. There are many. We are working in the sector model simulation since decades. So we have several library and system that we develop ourselves. Nowadays, let me say that for the part that is virtual extended reality, for instance, to give you an example, this one is a model for port security and safety. Is a project that we carried out between Italy and France with Toulon, with Bastia, with Cagliari Port, and we deal about to reduce the accident, etc. Ça, c'est une view. This is a view that allow you to, let me say, reproduce the port, see the coverage of camera, the range of risk of the area, changing the configuration of the port, and even to simulate. The project started 1 year ago. And in this case, we use that tool, Unity 3D, for the virtual realization, and it runs, as you can see, on a computer, but it can be even used on HoloLens, for instance. In this case, this is a nautical map. No? If you put the HoloLens on, you look at the map, you see the virtual scenario, you can change, you can interact, and so you see directly in a way that could be intuitive for Navy officer or people that deal with this environment, etc. And you can even having it running on your mobile. This is a simple Samsung, Android, but it could be whatever. You put not in HoloLens that costs 4,000 euro. You can put in Oculus that cost 400 euro. But you can put even on one simple headset that is just an holder for a Samsung phone, smartphone, and it costs probably between 4 and 40 euro, depending how cool it is, but it's mostly nothing. And you can use, obviously, capability are different. In this case, the model, simulation model behind is written in C# because it's the easiest way to connect with Unity 3D. We have a server that is making the hardest part of simulation and machine learning that is running on Java currently. We have about our student, to give you an idea what we teach mostly to carry out application in Python, because probably it's the easiest and now more popular way, but we was doing even some introduction with Java and other system that could be useful. In addition, we use even tool for simulation, but when we needed to create such couple, often is more efficient to do by programming, but there are many packages that could be used in order to make it work from, for instance, they do several things using AnyLogic, that is a package quite good for combining continuous discrete event, as well with other systems like FlexSim.
Another question: what can we do if we don't have enough information for simulation? There are the solution for small data.
Okay. As I told you, in one solution that could be maybe barbaric, but is to make hypotheses on data and check if they match. I give you an example. We was doing a work about a new vessel, okay? That was a carrier, aircraft carrier, to evaluate the operational cost and life cycle assessment in order to even define some requirement. It was a new vessel to be constructed. Now, when we talk about a military vessel, one big problem is that normally a new kind of a new class of vessel, or in this case, if we talk about European Navy, let's say all the Navy except the American, we do, and maybe a few other ones, but I would say all except the American. We talk about one new program for a frigate each 20 years and for few vessels. That means that 20 years ago, the last project used probably completely different technology. And all new system that you put on board in terms of major system, like propulsion, radar, cannon, missile, etc., are completely new. And being completely new often are developed with a new vessel. And often this means that we don't have data, not only, let me say, military data, but even data related to reliability, related to cost of operation at sea, at ground, at port, and so on. Time to make inspection, etc. We have hypotheses, we can define requirement, but it's something new. So to give an idea, in that case, there was over 300 variables of this kind to be set between the system subsystems of a vessel like that. That could be sensitive in terms of cost and in terms of configuration. So what, and obviously no data. We can ask to experts, but if you have to guess, if I take 40 experts for the different sector, maybe a couple for each one, and I ask to make the guess of each value, is just like to gamble. Okay, I can give guess, but it are very imprecise. So what we have done in such case, we create two different models. One model that was processing similar kind of vessels that already exist in the past, and find correlation, was used to find correlation among these variables. And it was created by analog, by expert suggestion, etc. And then we created some kind of simulation model, was coupled with the genetic algorithm. And genetic algorithm was using as basic the analogy from the analog model that was meta model, very simplified, putting inside the simulator that was simulating the tail of hypothetical operation and measuring the performance. And the genetic algorithm was going through to find a set of parameters that make a good solution in terms of reliability, availability, cost, etc., for such kind of different system and subsystem. And this was a way, let me say, to fill up such table of value that was not really available. The good point of using a genetic algorithm in that sense was that some of the solution was based on the suggestion by the expert where it was available. But to give you an idea, over around 300 variables, we had suggestion that was considered, let me say, good or to be used, that was around 80 parameter, 80, 90 parameter. So, and the system worked in such way. So you can try to do something that we call sometimes reverse simulation. So try to obtain what are the expect, because the analog model obviously don't say you what is the efficiency of the console for anti-aircraft operations, but it can say you what I expect in terms of availability of this system based on this was used to define a requirement, but in some way could be used to capture the parameters of the real system.
Thank you, Professor. We have to start the parallel session, and there are some questions, but I think they must.
If they write me or if we keep in touch, maybe I will be very glad to answer. I would like to thank you again for this big effort.
Thank you.
Je vous remercie beaucoup pour cela que vous avez fait dans cette situation de crise, et j'espère que nous avons bien sûr des possibilités de coopérer dans le prochain futur. Merci, professeur.
Prenez soin de vous. Merci. Au revoir.
Au revoir. À bientôt, j'espère.
À bientôt.
Okay. La Dada, vous avez quelque chose à nous dire? C'est tout? Oui, la Dada.
Oui.
C'est pourquoi
Est-ce que tu m'entends?
Oui, vous avez quelque chose à nous dire, à dire aux participants?
C'est commencer tout de suite après. Il y a 2 minutes juste pour installer et tester.
Et donc, là, il faut quand même faire une break de 10 minutes là.
Ben, moi, ça ne me dérange pas, mais il y a des gens qui attendent encore. ناخذ 5 minutes.
D'accord.
Il est 35, on commence à 45. 10h45, on commence les 2 sessions parallèles. Mais les sessions seront ouvertes dès maintenant pour que les gens puissent passer. D'accord? تسمعني يا أستاذ؟